Good day, Fatima. I'm your mathematics tutor, and my name is Okola Monsurat Olajumoke. Today, we talk about operations with binary numbers. I believe you must have been taught some things on binary numbers, like conversion of base 10 to other bases and vice versa. What binary numbers are all about. You should know that binary numbers comprise of zeros and ones. The highest digit or bit in a binary is 1. So the only numbers that we can have in a binary number are zeros and ones. So lesson objectives. In this video, you will learn how to add, subtract, multiply, and divide binary numbers. So by the end of this particular lesson, you should be able to add, subtract, multiply, and divide binary numbers. So the topics you must have known before you can move on to this, before you can watch this video, are addition, subtraction, multiplication, and division of natural numbers, which is same thing as numbers in base 10, the normal number we read every day, 1, 2, 3, and so on. And then you should know how to convert from base 10 to other bases, and also from other bases to base 10. So if you know these topics, then you'll be able to comprehend what is being taught in the lesson. Operations with binary numbers. The operations on binary numbers are the same as that of numbers in base 10, which I also call the natural numbers, that is the number starting from 0 to infinity. And you know that the operation we carry out on our everyday numbers are addition, subtraction, multiplication, and division, which is also the same for binary numbers. So we talk on these operations one after the other, and we cite examples on them. So the first operation is addition. You know, addition means adding two things together, two numbers together. Let me say two or more numbers together. So we discussed about the addition of binary numbers, how we can add binary numbers together. This is also based on some rules. You have to follow some rules. You know, you don't have to. The greatest number you have in your binary number is 1. So you learn how to do it so that you don't have any other number greater than 1. So this is what addition is all about. So the addition of binary numbers is performed by the following rules. So the first rule is 0 plus 0 is 0, which is the same for natural number, which is our everyday number. Also, we have that 1 plus 0 equals 1, which is also the same for natural numbers. 0 plus 1 is also 1, which is also the same, and 1 plus 1 equals 10. That is the only difference. This is where there is a difference between the addition of binary numbers and natural numbers. So 1 plus 1 will give 10. You write 0 there, then you carry 1 to the next significant bit. You know what is a bit? A bit is a single number in the set of binary numbers. For example, as we have 1101 base 2, 1 is a bit, 0 is a bit, this one is also a bit, and this one is also a bit. So we have 4 bits in this particular binary number. Binary numbers mean numbers in base 2. So now we already know the rules. 0 plus 0 equals 0, 1 plus 0 equals 1, 0 plus 1 equals 1, and 1 plus 1 equals 10. So now we move to examples on addition of binary numbers. So the first example says we should add 1101 base 2 and 101 base 2. You know, in binary numbers, if you want to arrange your number, you arrange them as if you are arranging them under units, tens, hundred, thousand, as you do in natural numbers. So here, there's also arrangement of numbers. You arrange your number accordingly. So the second question says add 1001 base 2 and 1011 base 2. So now we move to the solution of these examples. So please, we listen attentively to the explanation. So the first question says we should add 1101 base 2 to 101 base 2. You can see this is like the units, the tens, the hundred, and the thousand. So for 1012, this one will be under the units, the 0 will be under tens, and this one will be under hundred. So for this second number, we don't have 1,000. I think you understand this is just a primary school work. You arrange them under the units. So here we now have to follow the rules. From the rules guiding addition of binary numbers, we are told that 1 plus 1 is 10. So if you write 10, you write the number at the right side of the binary number, which is 0, and then you carry the 1. We already said from the rule here, we know that 1 plus 1 equals 10. So you write 0, then you carry 1. And that is what we did here. 1 plus 1, 10. You write 0, you carry 1. 0 plus 0 is 0, plus the 1 you carried is what? 1. 1 plus 1 is 10 from the rules guiding the addition of binary numbers. So you write 0, you carry 1. 1 plus this one is 10. 10 plus 0 is also 10. So you have to write 0, and then you carry 1 here. 1 plus 0 will now give 1. I think you should understand my explanation now. So let me re-explain. This is the units column. You add units to units, tens to tens, hundreds to hundreds, and thousand to thousand. And the rules guiding the addition of binary numbers says 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, and 1 plus 1 is 10. So 1 plus 1, 10. So you write 0, you carry 1. 1 plus 0, 1, plus 0, 1. You write the 1. 1 plus 1 is 10. That's 0, you carry 1. 1 plus 1, 10, plus 0 is still 10. So you write 0, carry 1. There's nothing here. So that's the one you carried will be here. 1 plus 0, which is 1. That is why we have 10010 base 2. Also, if you want to check if your answer is correct, since you know how to convert from binary numbers to base 10, you can convert 1101 base 2 to base 10, which will give us what? 1 times 2 raised to power 3, which is 8, plus 1 times 2 raised to power 2, which is 4. That's 8 plus 4 is 12. 0 times 2 raised to power 1 is 0. We still have 12. 1 times 2 raised to power 0 is 1, which is 1. So 12 plus 1 is 13. So 1101 base 2 equals what? 13 base 10. So if you convert this to base 10, we have 5. So 13 plus 5 is 18. So if you want to check if your answer is correct, you also convert this to base 10. So if you have 18, that means your answer is correct. So that is how to add binary numbers together and also check if your answers are correct. We are conversant with the addition of numbers in base 10. That is why I said if you want to check if your answers are correct, you can convert this to base 10. That is, if you are very fast, you have to be very fast, especially if you are in an exam hall, you have to be very fast. You convert this to base 10, you convert this to base 10, you add them together, you keep the answer. So the answer you got when you didn't convert to base 10, you also convert the answer to base 10. So if this is equal to the addition of these two numbers is in base 10, if it is equal, then your result, that is your answer here, is correct. So now we move to the next example, which is what? We are asked to add 1001 to 1011. So this is it, 1001 base 2 to 1011 base 2. This one shouldn't be difficult if you have understand the first example. So here 1 plus 1 is 10 from the rule. So 0, you carry 1, 1 plus 0, 1, plus 1, 10 is 0, you carry 1, 1 plus 0, 1, plus 0, 1. 1 plus 1, 10, you write 0, you carry 1, 1 plus 0 will give 1. So that is the answer. And also, another method you can use to add binary numbers, if you don't want to follow the rule 1 plus 1 equals 10. So another method you can use is, you add normally as if you're adding a base 10 number. 1 plus 1 is 2. Here we are dealing with base 2. Since 1 plus 1 is 2, we say 2, any number that is equal or greater than 2, you divide by the base, which is 2, then you only write the remainder. For example, 1 plus 1 here is 2. 2 divided by 2 is equals to 1, remainder 0. So you write the remainder 0, then you carry the 1, which is the quotient. You know what quotient means? If you divide a number by another number, the result you get is the quotient and the remainder. So here 1 plus 1 is 2, and you know we are dealing with base 2. 2 which you got here divided by the base you are dealing with, which is 2, is 2 divided by 2 will give you 1 with no remainder. That means your remainder is 0. So you write down the remainder, which is 0, and carry the quotient, which is 1. So you carry the quotient here, 1. 1 plus 0 is 1, plus 0 is 1. That's why we have 1 here. If you should apply the same thing you applied here to this place, so you have 1 plus 1, 2. You say 2, since the result here is equal to the base. If you have any result that is equal or greater than the base, you divide by the base and then you write down the quotient and the remainder. So you write the remainder here and carry the quotient to the next bit. That is the rule. So if you should follow that rule, 1 plus 1, 2, that 2 is equal to the base here. 2 divided by 2 is 1, remainder 0. You write down the remainder, which is 0, then you carry the quotient, which is 1, to the next bit. 1 plus 0, 1 plus 0, 1. That's that. So 1 plus 1, 2. 2 divided by the base, which is 1, remainder 0. You write down the remainder 0. You carry the quotient, which is 1. 1 plus 1, 2 is 2. You divide by the base. 2 divided by 2 is 1, remainder 0. You write down the remainder and carry the quotient. So here, this is 0, 0, 1, which is the quotient, plus 0, 1, plus another 0, 1. So you should apply the same method here. You get this. So we now have two different methods. It's either you follow the rule that 1 plus 1 equals 10, or you follow the rule that when you add two numbers together and it is greater or equal it is equal to the base or greater than the base, you divide by the base, you write down the remainder and carry the quotient to the next available bit. So that's the two methods you can use to add binary numbers. So we will still discuss more examples on the addition of binary numbers. So now we move to subtraction of binary numbers. So the subtraction of binary numbers also has rules. It's also in two forms. You can follow the rule or you follow the other way. I will explain when we get to the example. So the rules are also like that of natural numbers, which are also numbers in base 10. So the first one is 0 minus 0, which is 0. 1 minus 0, 1, that is normal. 0 minus 1 is impossible, so you have to loan from the next bit. and 1 minus 1 is 0. That's like normal subtraction of numbers. So now the next thing we look at now is the logic. The logic, how to borrow from the next bit, is the only logic we have to learn in the subtraction of binary number. So here we have to subtract 101 base 2 from 1110 base 2. I already told you how to check if your answers are correct. When we are talking about the addition, you convert to base 10, you subtract, and you see if your result here when converted to base 10 is also the result you have when you subtract the numbers you convert to base 10, as in the results you get. So now you subtract 1110 base 2 minus 101 base 2. From the addition, if you should borrow anything from here, from this bit to this bit, it changes to 10. And 10 minus 1, if you should convert 10 in base 2 to base 10, you have the number 2. So 2 minus 1 will give 1. That is the first rule. If you borrow from here, this will be 0. If you bring it here, it's going to become 10, which is 2. Since we are in base 2, 10 minus 1 will give 1, which is something I'm saying 2 minus 1 will give 1. So this remains 0. 0 minus 0 will give 0. 1 minus 1 from the rule will give 0, which is a thing we are very conversant with. You know that 1 minus 1 is 0, 0 minus 0 is 0, and 1 minus 0 is 0. That's normal everyday and subtraction. The only thing we have to listen attentively to here is how to borrow when you are subtracting in binary numbers. So the other method that I want to explain is, if you have something like this, the moment you borrow from here, this will be 0. 1, if you borrow 1 from here, this will be 0, like how we do when we were in primary school. And if you bring down 1 to this place, it changes to the base. Here we are dealing with base 2, it changes to the base, which is 2. So if you borrow 1 from here, when it comes here, it changes to the base, which is 2. So 2 minus 1 will give 1. The reason why it is 2 is that we are dealing with base 2 here. Assuming we are dealing with base 3, if we should borrow 1 from here, the moment it gets to this place, it changes to 3. So here we are left with nothing, since we borrow 1. 0 minus 0 will give 0, 1 minus 1 will give 0, and 1 minus 0 will give 1. That is the other method. It's either you follow the rule or follow the part that if you should borrow 1 from here, the moment it gets to this place, it becomes 2, since we are dealing with base 2. If you also borrow 1 from here, the moment it gets here, it becomes 2, since we are dealing with base 2. So that is that on subtraction. So we now move to the second example, which says we should subtract 1011 base 2 from 11101 base 2. So we move to the solution. 11101 base 2 minus 1011 base 2. So here, this is normal subtraction. 1 minus 1, 0. So this is what I explained. If we should borrow 1 from here, this will become 0. And if that 1 is brought to this side, since we are dealing with base 2, the 1 changes to 2. 2 minus 1 will give 1. Here we are left with 0. 0 minus 0 will give 0. 1 minus 1 will give 0, and 1 minus 0 will give 1. That is as simple as ABC. To check if your answer is correct, you convert this to base 10, you convert this to base 10, you subtract from each other, you get your answer. So you also convert the answer you got here to base 10 and see if it is the same with the answers you got when you subtract this converted to base 10. So now we move to the third operation, which is the multiplication. So now, multiplication of binary numbers also has rules. So this is also like normal everyday rule. So when we are multiplying numbers, like let's say when we are doing a long multiplication in the normal everyday number, you know that the first thing you do is to multiply, then later you add. So when you are multiplying, before you can get the multiplication of binary number, you should know how to add binary numbers together. You should be very conversant with the addition of binary numbers. So now we move to the rules. 0 multiplied by 0 is 0, 1 multiplied by 0 is 0, 0 multiplied by 1 is 0, and 1 multiplied by 1 is 1. This is the same thing, this is the same rule we follow in our everyday multiplication. So now we move to the examples. We have to multiply this 1110 base 2 by 10 base 2, and also multiply 10011 base 2 from 101 base 2. So I know for your stage you are very conversant with long multiplication. So now we move to the solution of the examples. So now first thing we do is to multiply 1110 base 2 by 10 base 2. So the first thing is we take this, use it to multiply the whole of this, then we take this, use it to multiply the whole of this. So the first one, 0 multiplied by 0 will give 0, 0 multiplied by 1, 0. When you're following the rule, 0 multiplied by 1 will also give 0, 0 multiplied by 1 will also give 0. So now move to this, and when you start multiplying with this, you shift inside a little bit as we used to do our long multiplication. So 1 multiplied by 0, 0, 1 multiplied by 1, 1, 1 multiplied by 1, 1, and 1 multiplied by 1, 1. So now the next thing to do now is to add 0 plus 0 will give 0, 0 plus 0 will give 0, 0 plus 1 will give 1, 0 plus 1 will give 1, 0 plus 1 will give 1. So to check if this is correct, you can change this to base 10, change this to base 10, multiply them together. When you change them to base 10, you multiply together, you write your answer. When you change this to base 10 too, if the conversion of this to base 10 equals to the answer you have when you multiply this in base 10 by this in base 10, then it means the answer is very correct. So now that is the solution. First question. So now move to the next question, which says we should multiply 10011 base 2 by 101 base 2. So follow the same rule as we did in the first question. 1 multiplied by 1 will give 1, 1 multiplied by 1 will give 1, 1 multiplied by 0 will give 0, 1 multiplied by 0 will give 0, 1 multiplied by 1 will give 1. So also use 0 to multiply the whole of this number, but when we get to the second, we have to move in, we shift in by a bit. So 0 multiplied by 1 will give 0. Let's start from here. 0 multiplied by 1, 0, 0 multiplied by 0, 0, 0 multiplied by 0, 0, and 0 multiplied by 1 gives 0. So use the third number. You can see we have 3 numbers here, so we have 3 steps. So the next transfer is 1, use 1, so it's shifting again. And see, when we finish using the first number to multiply, when we want to start with the second, we shift in a bit, and when we want to start with the third, we shift in a bit. So 1 multiplied by 1, 1, 1 multiplied by 1, 1, 1 multiplied by 0, 0, 1 multiplied by 0, 0, and 1 multiplied by 1, 1. You are through with the multiplication. So for you to get the final answer, you add all this together. So that is 1 plus 0 will give 1, 1 plus 0 will give 1, 0 plus 0, 0 plus 1, 1, 0 plus 0, 0 plus 1, 1, 1 plus 0, that's 0, plus another 0, 1 plus 0 is 1 plus 0 is 1. 0 plus 0 is 1, and 0 plus 0 plus 1 give 1. So 10011 base 2 multiplied by 101 base 2 we give 1011111 base 2. I can check if your answer is correct. So that is all about the multiplication of binary number. I can see it as simple as ABC. Is more or less like you multiplying a natural number or a number in base 10. The only rule is that when you are adding and you add two numbers or two or more numbers, and they are equal or greater than the base you are working in. Here the base we are working with is base 2. So if you should add any 2, 3 or more numbers together and it gives you a number 2 or numbers that are greater than 2, that is 2, 3 and so on, then you have to divide your answer by the base, which is 2. You write down the remainder and you carry the quotient to the next available bit. So that's the rule for addition. The rule for subtraction is that if you want to borrow from the left bit, when you borrow 1 from this bit and carry it to the right side, it becomes 2, since we are working with the base 2. So for multiplication, you multiply like we always do when you are multiplying your natural number. You use the long multiplication, and after multiplying you add together using the addition rule. So that is just a little revision on what we've been saying since morning. So now we move to the last operation, which is the division of binary numbers. So the division of binary numbers can be done in two ways. The first way is that you divide like we divide normally with numbers in base 10, or you convert the numbers you have to divide to base 10. You divide the numbers in base 10, then you now convert your answer back to base 2. So that's the method. So the first method comprises of the other two binary numbers, which are multiplication and then subtraction. If you are dividing a natural number 2, you multiply and you subtract. That is how to do the long division. You should be conversant with the long division too. I know that has been taught since primary school. So if you have forgotten, you go back to your primary school notes and you revise how you used to divide. So now we move to examples. So you divide 11010 base 2 by 101 base 2. So the second example says we should divide 11011 base 2 by 11 base 2. 11 base 2 can be another number in base 10. Like 11 base 2 now means 3 in base 10. 101 base 2 is 5 in base 10. That is it. You can just check that by converting. If you keep on converting, then you will be very, very conversant with it, and you won't make mistakes while converting from base 2 to base 10 or from any other base to base 10. So now we move to the solution of the first question, which says we should convert 11010. We should divide 11010 by 101 base 2. So the dividend, the number we are dividing, will be inside the box and the divisor will be outside. So the first thing we do is, can 101, we consider it as a normal natural number, 101. Can 101 divide 1? No, we can't choose that. Can it divide 11? No, it's not possible. Then 110 is greater than 101, and we can see 101 once in 110. 101, we can see it just once in 110. So that is why we write 1 here. As we normally do our long division, we say 101 multiplied by 1, we give 101. You arrange it. We are dealing with 110, 101, then you subtract. Here, the moment you want to subtract, you will use the subtraction of binary numbers. When we want to divide here, when we are looking for numbers to divide, we use our normal division, but when you want to subtract, you will use your binary you use the method for subtracting binary numbers. So it starts from here. What you do here, 0 minus 1 is impossible. So like I taught you earlier, you borrow 1 from here, this will remain 0, and when the 1 gets this side, it becomes 2. 2 minus 1 will give 1. This remains 0. 0 minus 0, 0, and 1 minus 0 is 0. So the next thing you do is, after that, you bring down this 1 as you normally do in our long division. You have 11. Can 101 divide 11? It is impossible. So that is why we write 0. The reason why we did not write 0 when we said 101 divided by 1 is that the 0 will still be insignificant. So if you write it or not, it's still the same. So 101 divided by 11 is impossible. So we write 0, and then we'll bring down this 0, and then we have 110. How many times can 101 go in 110? We have only one time. That is why we write 1. 101 multiplied by 1 is what? 101. So now we subtract 101 from 110 using the subtraction of binary numbers. So we now have, we borrow 1 from here, it becomes 2. Since we are working with base 2, 2 minus 1 is 1. This is left with 0. 0 minus 0 is 0. 1 minus 1 is 0. Since we did not have any number here again, we brought down all the numbers. So 1 here is the remainder, this is the divisor, this is the quotient, and this is the dividend, the number we are dividing. This is the number we are dividing. This is what we are using to divide. This is the number that remains, and this is the result we get when dividing this with this. So now we want to write the answer. We say the number we are dividing, which is on base 2, divided by its divisor, equals to the quotient with its remainder. So 11010 base 2 divided by 101 base 2 equals to 101 base 2, which is the result we have here. 101, it's also in base 2, and the remainder is what? 1. So is either you follow that method, or you follow the method of what? Converting each of the numbers to base 10. You divide them in base 10, then you do what? You will then convert that number in base 10 to base 2. So now let's start that. You should have been taught how to convert from base 2 to base 10. If you want to convert from base 2 to base 10, you know that you have to write the powers of your base, which is 2 here. Starting from 0, you have 0, 1, 2, 3, 4. That is why we have the first one is 1 multiplied by your base, which is the power we have here, which is 4. 1 multiplied by 2 raised to the power 4. That is, the bracket will be closed, plus the base, the power here is 3, the base is 2, and 1 multiplied by 2 raised to the power 3, plus 0 multiplied by the power here is 2, and we all know that we are working with base 2. 0 multiplied by 2 raised to the power 2, plus 1 multiplied by 2 raised to the power 1, plus 0 multiplied by 2 raised to the power 0. So you should know that in indices, 2 raised to the power 0 is 1, and anything multiplied by 0 is 0. So this 0 multiplied by this is 0, and 0 multiplied by 2 raised to the power 2 is 0. So that is 1. So we have to stay with this. 2 raised to the power 4 means multiplying 2 4 times. 2 raised to the power 3 means multiplying 2 thrice. So 2 raised to the power 4 means 2 multiplied by 2 multiplied by 2 multiplied by 2, which is what? 2 multiplied by 2 is 4. 4 multiplied by 2 is 8, and 8 multiplied by 2 is 16. That's why we have 16 here. Here we have to multiply 2 thrice, which is 3 times. 2 multiplied by 2, 4, and 4 multiplied by 2 is 8. We already say 0 multiplied by anything gives 0. 1 multiplied by 2 raised to power 1 is simple as saying 1 multiplied by 2, which is 2, and also the rule that guides this also guides this. 0 multiplied by anything will give 0. So now we add the numbers together. 16 plus 8, 24, 24 plus 0, 0, 24 plus 2, 6, and 6, 24 plus 2, 26, and 26 plus 0 will give 26 base 10. You know, we converted to base 10. Also, we convert 101 base 2 to base 10, and that is given here. 101 base 2 to base 10 will be equals to what? We do the same thing as we did for the other number. So this is 0, 1, 2. 1 multiplied by 2 raised to power 2 plus 0 multiplied by 2 raised to power 1 plus 1 multiplied by 2 raised to power 0. So 2 raised to power 2 is 2 multiplied by 2, multiplied by 1 is 4. 0 multiplied by anything will give 0, that's why I did not bother to write anything. And 1 multiplied by 2 raised to power 0, you know 2 raised to power 0 is 1. Anything raised to power 0, any number raised to power 0 is 1. So 1 multiplied by 1 will give 1. 4 plus 1 will now be 5. So 101 base 2 is simple as writing 5 in base 10. That is the natural number. So now, dividing this by this is simple as saying 26 divided by 5. I know 26 divided by 5 will be 5 remainder 1, because 5 multiplied by 5 will give 25, and 25 plus 1 will give 26 back. So this is the remainder we have in the former result. So the only thing we have to do now is to convert 5 to base 2. And you know, if you want to convert from base 10 to base 2 or to any other base, you divide your number by that base. So now we convert 5 base 10 to base 2. So you write 5 here. 2 in 5, that is 2 remainder 1. You know, 2 in 5, 2 times 2 is 4. And 5 minus 4 will give 1. So that is why we have 2 remainder 1. So we divide by 2 again. 2 divided by 2 is 1 with no remainder. That's why we have remainder 0. And also we divide by 2. 2 divided by 1 is impossible, but we have a remainder. Since we can't divide, we still have this remainder 1. So now we have to write is the remainder you will write. So we start from the bottommost remainder 1, 0, 1. So 5 base 10 is 101 in base 2. So now you can see that 11010 base 2 divided by 101 base 2, which is now saying 26 base 10 divided by 5 base 10 is equals to 5 base 10, which is something as 101 base 2 remainder 1. So that is that. We can also follow the same. So this is the second example. Here I only use the long division method. I did not use the conversion of base 10. So you can try converting to base 10 here and check if it's going to be the same. So now let's use the long multiplication to divide 1, 1, 1, 0, 1, 1 by 1, 1. What is the first thing to do here? You consider this as 11. Can 11 go in 1? That is impossible. So you pick another one. Can 11 go in 11? That is true. So 11 can go in 11 once. And 11 multiplied by 1 will give 11. If you subtract using the subtraction of binary number, 1 minus 0 will give 0. 1 minus 0 will give 0. That is why we did not bother to write anything. So that is 0, 0. We bring down this one. Can 11 go in 1? That is impossible. We write 0. 11 multiplied by 0 will give 0. So you don't even need to do that. If you are very conversant with long division, that's going to make your work longer. If you want to do that, it's going to make your work longer. So since it is impossible and you've written your 0, you break down the next number, which is 0. Can 11 go in 10? You should know that 10 is less than 11, so that is also impossible. So the next thing to do now is to bring down the next number again, making 101. How many 11 can you see in 101? You know, on a normal day, you are supposed to write 9 or 10, but since we can't write a number that is greater than 0 and 1 in binary number, The only thing you have to do now is to say that you can only see 11 once in you can only see 11 once. So that I say 11 multiplied by 1 gives 11. So now using we subtract using the subtraction of binary numbers. 1 minus 1 will give 0, and here you bring the rule. If you should borrow from here, this will become 0, and when you bring it here, it becomes 2. 2 minus 1 will give 1. So here we have 1 0. So now we bring down the next number, 1. How many times can 11 go in 101? Same thing as this. So you say 1. So 11 multiplied by 1, 11. You subtract 11 from 101 using the subtraction of binary numbers, and you have 10. You should know 10 is now less than 11, so it can't go. So it means 10 is the remainder. This is the quotient, the value we get by dividing this with this, and this is the divisor. This is what I'm dividing it. So 111011 base 2 divided by 11 base 2 will give 10011 base 2, remainder 10. So if you want to check if this is correct, you can use the second method. You change this to base 10, you change this to base 10, you divide with each other. In that base 10, you convert your results to base 2. You convert your results to base 2. After converting your results to base 2, then you check, the moment you divide, your remainder will come out. The only thing you have to do is to divide the whole number, is to convert the whole number to base 2. But I hope you understand what I've been trying to say. So now just look at one more example, which is like checking if you really understand the multiplication of binary number. So here we are to check whether 11 base 2 raised to power 4 is same thing as 1001 base 2 raised to power 2, which is same thing as 101 base 2. So the first thing to do here, we expand this, we keep the answer, we expand this, we keep the answer, and we'll check if the result we get here is same thing as the result we get here, which is same thing as this binary number. So the first thing to do is expand 11 base 2 raised to power 4. What is 11 base 2 raised to power 4? Is 11 base 2 multiplied by 11 base 2 multiplied by 11 base 2 multiplied by 11 base 2. So we take it one after the other. 11 base 2 multiplied by 11 base 2. So this is it. 1 multiplied by 1, 1. 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 So now we had 1 plus 0, 1. 1 plus 1, is 2. I say if you have a number that is equal or greater than your base, you divide by the base, you write down the remainder and carry the quotient. So 1 plus 1 is 2. 2 divided by 2 is 1, remainder 0. The remainder is 0, you write down 0. The 1 is the quotient, you carry 1 to the next available bit. So 1 plus 1 will also give 2. 2 divided by 2, which is the base, that's 1, remainder 0. We write down the remainder 0 and carry the quotient 1 to the next available bit. 1 plus 0 will give 1. So that is it. So we multiply by the next 11 base 2. We want to multiply 11 base 2 4 times. So the next one, 1001 11 multiplied by 1001 base 2 multiplied by 11 base 2 is going to be 1001 multiplied by 1. So if you are multiplying by the second one, you shift in a little bit as I have taught earlier. So now we check how to do that. This is it. First one, you use 1 to multiply 1001 is 1 multiplied by 1, 1. 1 multiplied by 0, 0. 1 multiplied by 0, 0, and 1 multiplied by 1, 1. So the next one is to use the other one to multiply 1. We shift in a little bit. 1 multiplied by 1, 1. 1 multiplied by 0 0, 1 multiplied by 0 0, and 1 multiplied by 1 1. So what we do again is we add using the addition of binary numbers. 1 plus 0 1, 0 plus 1 1, 0 plus 0 0, 1 plus 0 1, and 0 plus 1 1. So now we multiply by the fourth 11 base 2. Since we are dealing with 11 base 2 raised to power 4, we multiply 11 base 2 4 times. So now this is the fourth multiplication. 1 multiplied by 1 1, 1 multiplied by 1 1, 1 multiplied by 0 0, 1 multiplied by 1 1, 1 multiplied by 1 1. So multiply with the second one here, we shifting a little bit like we do in the long multiplication. 1 multiplied by 1 1, 1 multiplied by 1 1, 1 multiplied by 0 0, 1 multiplied by 1 1, 1 multiplied by 1 1. So you had using the binary addition. I'm not going to discuss this. You can check it on your own and see if you really understand how to add binary numbers. So now this is the final result. When you multiply 11 base 2 4 times, you have 1 0 1 0 0 0 1. So you keep the result. So now we keep the answer for 11 base 2 raised to power 4, which is this 1 0 1 0 0 0 1 base 2. So move to the second one. We also expand 1 0 0 1 base 2 raised to power 2, which is like multiplying this twice. So 1 0 0 1 1 0 0 1. We multiply it. You should know how to do that. You first use this one to multiply the whole of this. You write the result. You use this 0 to multiply the whole of this. When you're multiplying, you move in a little bit. You use this 0 to multiply the whole of this. You move in a little bit than this. You move to the third column. You multiply. When you multiply, then use 1 to multiply, which is the last number. Then you start from the second column. So when we want to use this one to multiply, 1 multiplied by 1 1, 1 multiplied by 0 0, 1 multiplied by 0 0, 1 multiplied by 1 1. So we move to the second number, we shift to the next column, start from the next column. 0 multiplied by 1 0, 0 multiplied by 0 0, 0 multiplied by 0 0, 0 multiplied by 1 0. We also use this 0 to multiply. You start from the next column here, which is the third column. 0 multiplied by 1 0, which is here. 0 multiplied by 0 0, 0 multiplied by 0 0, 0 multiplied by 1 0. So use the last one to multiply. 1 multiplied by 1 1, 1 multiplied by 1 0, 1 multiplied by 1 multiplied by 1 1, 1 multiplied by 0 0, 1 multiplied by 0 0, and 1 multiplied by 1 1. So you had the 4 rows together. You had the 4 rows together, this, and this. And if you add them together using the addition of binary numbers, you get this. Therefore, this base 2 raised to power 2 will also give this. Since 11 base 2 raised to power 4 gives this, and 1001 base 2 raised to power 2 also gives, consider it's the same. 101 0001 101 0001 base 2. Therefore, the assumption is correct that 11 base 2 raised to power 4 is the same thing as writing 101 base 2 raised to power 2, which all gives us what? 101 001 base 2. So that's about operations with binary numbers. So these are assignments for you to solve and upload where you normally upload your assignments. It should be submitted latest by tomorrow evening. So I wish you best of luck. So I wish you best of luck. Now our next video will be on word problems with sample questions and solutions. Please contact me if there's anything you don't understand in this video so that I can give you further explanation. Thank you very much.